This problem is a lot like the one assigned for homework. That is problem 21. Find the derivative using the limit definition. So we're going to first use the limit definition and find f prime of x, and then we'll plug in x equals 1 to find the derivative at x equals 1. Next, we'll show that 1 comma negative 2 is a point on the graph of y equals negative 2x squared, and finally we'll find the tangent line at x equals 1. So f of x equals negative 2x squared. F of x plus h would be replacing x in the equation of f of x with x plus h. So wherever you see an x, replace it with x plus h. So that's f of x plus h. First, write down the limit definition, which is limit f of x plus h minus f of x divided by h as h approaches 0. So that's equal to limit, and then we plug in f of x plus h, which is equal to negative 2 times x plus h the whole squared minus negative 2x squared whole divided by h, and that's equal to the limit as h approaches 0 minus 2 times x squared plus 2hx plus h squared plus minus 1 times negative 2x squared is positive 2x squared. So x plus h the whole squared is square the first plus twice the product of the two plus square the second. So that's how we get x squared plus 2hx plus h squared plus 2x squared. Now distribute the negative 2. So that's negative 2x squared minus 4hx minus 2h squared plus 2x squared. So plus 2x squared minus 2x squared gets cancelled. We're left with minus 4hx minus 2h squared. Remember that at this point, when you substitute when you substitute h equals 0, you get a 0 over 0, and that's why we simplify it completely. And our goal is to cancel the h in the denominator with the factored h in the numerator. So we have come to a point where we can factor out the h. So once we factor the h out, it gets cancelled with the h in the denominator. So we are left with limit as h approaches 0, negative 2 times 2x minus 2h. At this point, we need to find limits, and it can be done by substituting h equals 0 because the h in the denominator is cancelled. So we don't have a 0 in the denominator. So once we substitute h equals 0, we get negative 4x. So what we've shown is that f prime of x is equal to negative 4x. So what is f prime of 1? We plug in x equals 1, so it's 4 times 1, which is negative 4. So f prime of 1 equals negative 4, which is the same as saying that the slope of the tangent line to the graph of y equals negative 2x squared is equal to negative 4. So remember, the original graph was f of x equals negative 2x squared. That was the function. So if I draw a tangent line to this the graph of this function at x equals 1, then the slope of the tangent line equals negative 4. Next, we're going to check if the point 1, negative 2 lies on the graph of the given function. So our given function is f of x equals negative 2x squared. So here we are not talking about the derivative. We are talking about the original function, and we are checking to see if a certain point sits on the graph of that function. There are two ways in which we could do it. So if we want to show that 1 comma negative 2 is a point on the graph, we can plug in x equals 1 and show that f of 1 is equal to negative 2, which means y equals negative 2 when x equals 1. So we plug in x equals 1 into the original function, not the derivative, because we're talking about this point lying on the graph of the original function. So f of 1 is equal to, when we simplify it, is -2. So which means when you plug in 1 into the function, you get -2. This tells us that this point lies on the graph of the function. Okay, so the next step or the next method by which we can prove the same thing is by writing y equals -2x squared, plugging in, since we're trying to prove that 1 comma -2 is a point on the graph, plug in x equals 1, y equals -2. So once we plug that in, -2 is equal to -2 times 1. So -2 equals -2, which is a valid equation which tells us that 1 comma -2 is a point on this graph. Now, if it weren't a point on this graph, we would get something like -2 equals 1, for example, which is not true, which tells us that the point does not lie on the graph of the function. So we have proved in two different ways that 1 comma 2 is a point on the graph. Now, finally, if we had to find the equation of the tangent line, we need a point and we need the slope. We know that the point is 1 comma -2. At x equals 1, f prime of x, when I plug in a 1, is equal to -4. So f prime of x is equal to -4x. If I plug in a 1, I get -4 times 1, which is equal to -4. So the derivative of the function, which is also equal to the slope of the tangent line at x equals 1, is -4. So the slope m is equal to -4. A specific point on the graph, we just proved that 1 comma -2 lies on the graph, and we get the equation y minus y1 is equal to m times x minus x1. That's our point slope form. So y minus y1 is equal to -2 is equal to m, which is -4, times x minus x1, which is -1. So this is equal to y plus 2 is equal to -4x plus 4. Subtract 2, and that is equal to y equals -4x plus 2. So this is the equation of the tangent line. And if we had to sketch the graph of the function y equals -2x squared, remember the graph is reflected. So first of all, we can sketch y equals 2x squared, which is the point. Let's just start with the graph of y equals x squared. So that if that is a 1, 1, then multiplying the function by 2 would mean stretching the graph in the vertical direction by a factor of 2, which means the new point becomes 1, 2, which means we multiply the y coordinate by 2. We know that it passes through 0, 0, and it's symmetrical, so there's a symmetrical point on this side. That is the graph of y equals 2x squared. Next, we reflect it across the y-axis because we're trying to sketch the graph of y equals -2x squared. That would mean reflecting across the x-axis. So this pink graph is the graph that we need, and the point 1 comma -2 probably lies about here. I'm just this is a rough sketch, and we can draw the tangent line to this graph, and clearly the tangent line will have negative slope because we know it's -4.